now we're going to take a look at how to solve inequalities. Now, the word solve is the same for when we're solving an equation. Remember, it's not an inequality, it's an equality, an equation when both sides are equal to each other. And this is very similar, but they're not exactly equal. It could be less than or equal to in this instance. So because it technically means something very similar, the process in which we solve these is exactly the same. So what we have is a term with letters, a number term, and another number term. So there's only one letter term, and that's on the left, so we need to collect that on the left, so keep it there. And the number terms, these two, have to be on the other side. So this one is in the wrong place, so that's what we're going to get rid of. So to get rid of this -3, I'm going to add 3, and if I do it to this side, I must keep it balanced and do it to the other side. So put your inequality sign down, normally in a straight line, and on the left hand side I'll have 2x, and on the right hand side I will have 12. Now 2x's, treat it like an equal sign, so 2x equals 12, so 1x will equal 6, but of course it's not an equals, it's an inequality. So what this stands for is x is less than or equal to 6. Now they could go a little further and say what is the highest integer this could be, and that would be 6 in this instance, because it can equal 6. Let's have a look at this one. This one's slightly harder because there's an x term, or an unknown term, on both sides, so we have to collect them on one side first. And because this has the most, we're going to remove this 2x by subtracting 2x to both sides. So giving me on the left hand side 3x plus 1, and on the right hand side just 10. Now it looks just like before. So the letter terms are on the left, the number terms must be on the other side. So I'm going to remove this plus 1 by subtracting 1, and I'm going to do that to both sides, leaving me with 3x and 9. So to find out what x would be, if I've got 3 of them, I would simply divide by 3, so x is 3. So x is less than or equal to 3. That should be very, very familiar to you now if you've learned how to solve equations. If you haven't, you should be doing that before watching this video. Here's another one. This time the highest amount of x is on the right hand side. Just watch the ending and pay particular attention to the ending because it's a little bit tricky. So because this is the most, the x's now we're going to collect on the right hand side. So I'm going to remove this one by subtracting 3x to both sides. So put my inequality sign down. On the left I'll just be left with 12, and here I will now have 5 x's, take away 3. So because the letter terms are on the right, the number terms, these two, must be on the left. So this one's in the right place, this is in the wrong place, so I need to get rid of it. To remove a -3 I must add 3, do that to both sides, and I will get 5x and 15. To find what a single x is, I need to divide by 5, and we would have 3. Now, previously we spoke about this, so 3 is less than or equal to the number, and if you were listing integers, we discovered that it is exactly the same as swapping the x and the 3 round, but if you do that, you must change the direction of your inequality. These two mean exactly the same thing, but a lot of people are more happy looking at it like this. There's one more like that, we'll run through it quickly. So remove 5x from both sides, leaving me with this. The 6 is in the wrong place, it's on the wrong side because this is where the letters are, so I'm going to subtract 6, leaving me with that. And now I can divide by 4 to get a single x, which would be 9. And again, not many people like looking at it like this, so if I swap these over, I change the direction of the inequality. It means exactly the same thing. And there we have it. I'm going to show you some trickier solving ones, so you might want to practice these first and then watch the next video.